Geotrig, this is lesson 29. We're going to talk about the unit circle today. What we're going to do is we are going to build the unit circle. The unit circle, there is a circle, yes, centered at 0, 0 with a radius of 1. And so what we're going to do is we are going to use our two reference triangles for all the multiple angles or multiples of 30, 45, 60, and 90, and we are going to be able to create this unit circle. The unit circle is really nice because it puts together the fact that there are angles larger than 90 degrees that you guys will have to do sine, cosine, and tangent for. They end up lying in different quadrants. And those different quadrants, and for us right now, we're going to focus on the easy stuff, which means it is going to be a multiple of the 30, 45, 60s, and 90s. Those are the ones that we have reference triangles for. Those are the ones that will be in our unit circle. Even though we should eventually, now you'll have to use a calculator, but you guys could take the sine of 3 degrees, or you could take the sine of 177 degrees. That can be done on a calculator. It'll give you an approximation. That's fine. But what if we don't have those calculators? What if we made it one of these nicer angles that we remember? So, fair warning. You will have to use this next year if you're taking pre-calc or going on to some of the other classes. What you're also going to have to do is you're going to have to construct the unit circle with degrees and all of their points in under 2 minutes. That's my thing that I have you guys do. When you guys get to pre-calc, and if you happen to have me again, if I teach that, you'll have to add the radians in under 3 minutes as well. So, guys, an important part of this unit circle is this thing right here. The unit circle, and we're going to get to this what it looks like in a second. The unit circle is made up of points that are going around the circle at intervals of 30, 45, 60, and 90 degrees. And so each one of those points is going to be made up of an x, comma, y. And x, comma, y is cosine theta, sine theta. Okay? Now, we also should know, hopefully, I think we talked about this earlier because we talked about SOHCAHTOA, that tangent theta is the same thing as sine theta over cosine theta, which in reality, on the unit circle, tangent theta is y over x. The unit circle, guys, does not include tangent. It just has cosine theta, comma, sine theta. But what we can infer from this, it's the y over the x, or it's the sine over the cosine. You can have tangent. So it's going to allow us to say, hey, what's the tangent of 135 degrees? So you'll be able to go to your unit circle, go to 135 degrees, look at the x and the y, divide them, and you have an answer. Makes it a little bit faster or maybe a little bit easier than trying to use the reference triangles themselves. So, what does it look like? That is the unit circle. You guys are getting these today. So, how are we going to use this? Okay. The way this is actually created, guys, is with our reference triangles. Now, maybe we should go to another page here and create those unit circles, or maybe I'll just fit in the corner here. If I wanted to make a 30, 60, 90 triangle, and then we'll put the 45, 45, 90 on the bottom. You guys should know that I like to create these the exact same way every single time. Yes? Because I can quickly put their sides on. Go back to the 30, 60, 90. What are the sides on this thing? It's 1, 2, 3, and the square root goes on the 3, the larger number. Going to the 45, 45, it's 1, 1, 2, square root. Here's the problem. Not the problem. Here's the situation. If I asked you what's the sine of 30, you guys could use those triangles, and you would say it's opposite over hypotenuse, which is 1 over 2. If I asked you the cosine of 60, you would say, oh, that's 1 over 2. If I asked you the tangent of 60, you're like square root of 3 over 1. Very easily done, yes? Now here's the thing. This circle is only got a radius of 1. Which means every single one of these lines that are represented right here actually only has a length of 1. That is, now watch what happens. If I drop a line straight to the x-axis, it forms a right triangle. With the x-axis, the vertex, and the terminal point at the end. That triangle right here is this one, or it's this one. It's one of these two reference triangles. Every single one of these places is made up of one of those. But the problem is, this is where 1 is. But 1 is actually supposed to be, that's supposed to be here. Because this is 30 degrees. And so, if I'm supposed to have a 1 at the hypotenuse, or aka the radius, which is the hypotenuse here, I have to divide it by 2. So, I'm going to take this, and I'm going to divide by 2. But if I divide one of the sides by 2, we talked about this, they're all the same ratio, right? So now we get 1. I can do the same thing over here and divide everything by square root of 2, because now that's 1. And then you get 1 over square root of 2. 1 over square root of 2. So that means that this triangle has a 1/2 at the end, square root of 3 over 2, and 1. Now we're only going to do this for a couple of these. Look, if I want to know this point right there, how far to the right do I go? Square root of 3 over 2, and then go
Up 1/2.
up 1/2. So what's the point?
Square root of 3 over 2.
Square root of 3, 1/2. I used the reference triangle on the unit circle, and I was able to find the point. What do you think the next angle is? What's the next angle? It's 45.
Yeah. So we have 1.
So this is 45. So that means this is still 1, right? That's 1.
Yeah. So what would be 1/2? 1 over square root of 1/2. And then
1 square root of 2.
Yeah.
1 over square root of 2. So how far to the right and up?
So it would be 1/2. 1 square root of 2 over 1 square and 1 square root of 2.
But technically, guys, I don't like 1 over square root of 2. It'd be square root of 2 over 2.
Okay.
So if I was to clean this up, I would not leave it as 1 over square root of 2. I'd put square root of 2 over 2. I'm going to leave it this way for now because we're kind of going through the process. What's the next line?
Oh. Would it be 360, 30? Or 36,
So this one
36.
is 60.
Oh,
And so opposite 60 is square root of 3 over 2. Opposite the 30 would be 1/2. And there's your 1. So what's the point? Going all the way over and up.
1/2. 1/2. Square root of 3 over 2.
Square root of 3 over 2. So I am going to pause it. Actually, let's clean this up here. This was 60, 45, and 30, right? I want you guys to skip this one, which is supposed to be what? 90. I think we all agree that we got 90 degrees. We'll talk about that one next. I want you guys to do this next one here. What is this angle? It's going to be a 60 degree, but it's not 60 to here. It's 120. I then want you to do 135 and 150. I'll give you guys a couple seconds to do exactly the same thing by building triangles. Okay, at 120, I'm going to take these two out of here to get them out of the way. If I draw my triangle, what kind of angle is resulting here? That reference angle. It's 60 because it took you 120 to get to this point. What would it take to get to the x-axis? 60. So this is a 60 degrees, which means 1/2 is below. Square root of 3 over 2 is on its side, and 1 is the hypotenuse. Yes? Here's the problem. Is it really 1/2? It's negative 1/2 because I'm going backwards. And so, the point is, negative 1/2 square root of 3 over 2. Are we catching this? Are we getting the idea that every single time it's either a 60, 45, or a 30 degree angle? Is this taking a long time? Yes. The next one, it is the same numbers, and that's what's going to make this thing go a lot faster. This one at 135 is a 45 degree angle, which is 1 over square root of 2.
30, 45, 30, 45, 30,
It's just-
45, 30.
All you have to do is just
Yes, and again, I'm going to show you guys the quick way of doing this in a second. But I'm going backwards and then up, so it becomes a negative 1 over square root of 2, 1 over square root of 2. Don't tune me out just yet. Give it a chance here, guys. And the last one that we'll do for today is at 150 because it has a 30 degrees, which means 1/2. There's 1 and square root of 3 over 2, but it is negative. So the point is negative square root of 3 over 2, comma, 1/2. Now, I would love for you guys to continue that around the circle, building it exactly the same way. Okay? But we seem to be skipping things. How come we didn't start out at 0? How come we skipped over 90? Then we over here, we just left it and we did not finish it, but this would be 180 degrees. Here's the thing, guys. And then again, 270 below. 270. Now, here's the thing. If I'm at 0, 0, and I'm on the unit circle that has a radius of 1, if I go straight to the right, how far did I go and where am I?
You went
1, 0. If I started at the center and went straight up, and -1, 0, and last one, 0, -1. Now why is this happening, guys? Because isn't this the sine, or cosine, comma, sine? Cosine, comma, sine. What's the cosine of 0? Cosine of 0 is 1. What's the sine of 0? 0. What's the cosine of 90? 0. What's the cosine, or the sine of 90? 1. And we can do that all the way around the circle. Just like I can ask you, hey guys, what's the cosine of 60? It's the x value, which is 1/2. Okay? Now, what we can do here, I'm going to get away from this circle thing here. And we're going to talk about those quadrantal angles. That 0, the 180, the 90, and the 270. These are called quadrantal angles. These quadrantal angles, there is no triangle. If I'm forcing a triangle in here, if you took a 0-degree angle and forced a triangle, is there really any height to a 0-degree turn? No. There is no height. And so if there's no height, but if I forced it, somehow, miraculously, I get this height, you end up with this triangle-looking thing that doesn't seem to make sense. It works out really nicely with 0 and 180. Because at 180, all the way over here, you'd also have a 0 reference angle, and the same situation happens. Whoa, what's the cosine of 180? -1 over 1. It's -1. The sine of 180, or the sine of 0, over on this side, is still 0 over 1, which is still 0. It's a little bit tougher this way. What if I forced a 90-degree right triangle of a 90-degree triangle? Like a right... Okay, let me rephrase this. Let me force an extra 90-degree angle in a right triangle. Because this... Yes. Can you form a triangle there? They don't really exist, do they? Right. So, based off of this, what is the sine of 90? 1 over 1, which is? 1. And that was true on there. But what's the cosine of 0? 0 over 1, which is 0. That's, I'm trying to force the triangles that we've been doing all the way around in, but it's obviously not working here. But if I force it to happen, we can kind of see that the same sine, cosine, tangent stuff will still work. So, we came back to a blank unit circle because I will be requiring you guys all to fill this in. Degrees in all of the terminal points in under 2 minutes. And so, there are some things that you guys are going to have to know. You're going to have to be able to count by 30s, 45s, and 60s, and 90s. So the first thing I would highly suggest, and this is not the only way to make this happen, is to go in and put all of your degrees. So 0, 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240,
Messed up.
270,
Fine.
300, 315, and 330. Once you have all of your angles in there, I want you to put your quadrantals in. Quadrantal angles. 1, 0. 0, 1. Negative 1, 0. And 0, negative 1. Okay? Everybody's good? Then I want you to say, hey, wait a minute. Doesn't it seem kind of weird that all of the extra little lines and places seem to have a fraction bar?
Yeah.
So I want you to go and put 2's underneath every single one of them.
Which one? The second line.
2, 2, 2, 2, 2, 2. They're kind of right down the middle, don't you think?
Your sneak peek. Sneak peek. Everything is skewed.
So now that you have 2's underneath all of your fractions,
Put ones on everything.
I want you to go to the tops of everything and put a square root
On every one of them?
on every one.
I don't like that.
You can fit them, Tyler. Don't even sit.
Now, as we're doing this, I am not looking for the most neatest of things when I'm correcting. I am looking for the ability to tell what your numbers are and that you get the idea. So as long as I can read it, we're going to be A-okay. Now, here's the cool thing that makes this so wonderful. Go back to your example, guys, of yours half filled in unit circle. Do you notice that it seems to go, well, actually yours isn't completely because we didn't fix the square root of 2's over 2's, or the 1 over square root of 2's. But what happens is it goes 1, 2, 3, 3, 2, 1. And so this is what I propose. If you are starting at 0, let me change the direction here. If you start at 0, the next logical number when going up is 1. So it's 1, 2, 3.
3, 2, 1.
And then 1, 2, 3 on the way back down. You've now just filled in the first quadrant. I always use the quadrants as my anchors. The x has the 0, so over here I'll start at the x's and put
1.
1, 2, 3, and then go back up. 1, 2, 3. Going to the third quadrant. Now it's the y's. 1, 2, 3, 1, 2, and 3. Going to the fourth quadrant, it's the x's again. 1, 2, 3, 1, 2, 3. You are almost done. The only thing that we still have to do is put negatives. So the question is, where are things negative? In the second quadrant, all of the x's are negative. In the third quadrant, y and x are negative. In the fourth quadrant, only the y's are negative. You have now just created the unit circle. You guys have practice time. Have a great night.